In previous units, you have spent much time talking about equations. But now we're going to turn our attention to inequalities. So what's the difference? Well, first of all, equations use an equal sign. Inequalities use symbols like less than, greater than, not equal to, or maybe less than or equal to, or greater than or equal to. Equations have an equal sign and take on forms such as this. 3x plus 5 is equal to 11. And we can solve equations. Inequalities will take on the form 3x plus 5 is less than 11. Now, where equations have only one answer, so in this case, x is equal to 2 would be the solution to this equation. Over on the other side, with inequalities, any number less than 2 would work. And the great thing about inequalities is we can graph them. We can also, at least the solution that is, we can also graph the solution to an equation as well. So let's just show you this. If we graph the solution to this equation, then on a number line, we could have numbers like -2, -1, 0, 1, and 2. And the only number that works on this equation and in this equation is 2. So I'm going to put a point at 2 to show that's the only one that would work. In an inequality, we could take the same number line, -2, -1, 0, 1, and 2, and we could say, well, 2 doesn't work because 2 would make the equation or inequality equal, and we don't want it to be equal. But any number less than 2 would work. So our focus is going to be on the inequalities now. We solve them very similar to equations, except for one strategic idea. So let's introduce you to inequalities now. This is less than. And when we see less than, we could see inequalities that could say x is less than 7. We also have greater than, like x is greater than 8. And we also have not equal, or not equal to. So inequalities are comparing two unequal amounts. Now, we can use different phrases with inequalities, such as, let's take a look at this. A number is at least 30. If we wanted a number that was at least 30, we could use 30. Could we use 31? Yes. If it's at least 30, that means that's the smallest it could be. So if we wrote this as an inequality, this could be something like x is greater than or equal to 30, meaning any number 30 or more would work. We can also use phrases such as this. The cost is at most $20. So let's say we're going on a youth trip for church and your youth pastor says the cost is at most $20. That means that's the most it could be. It could be 19. It could be free. So here we could say x is less than or equal to 20. So it could be 20, but it could be less than that. how do we graph inequalities? Well, let's take a look at that. So let's say that we have x is greater than or equal to -3. Now, to graph the solutions to this, and more about those in a moment, we're going to make a trusty number line, and we're going to make a mark, and we're going to put -3 right in the center. Now, we could write other numbers to the left and to the right if we wanted to, but it's not necessary to. You know the numbers on the number line. So I asked myself, can I use -3? Well, if I put -3 in this inequality, is -3, so let's think about this, is -3 greater than or equal to -3? So is that true? And the answer is yes, that is true. So we like -3. -3 makes this work. So we're going to put a closed circle at -3. That means we're going to include -3 in our solution graph. Now we want all the numbers that are bigger than -3. Well, all the numbers bigger than -3 are to the right on a number line, so we're going to put some squiggles in to show that. And that's how we graph. Kind of fun. You get to squiggle, squiggle, squiggle. What if we have something like x is less than 0? Okay, we'll make a number line, and we'll put 0 right in the center. Now we evaluate 0. Is 0 less than 0? Well, no, that's not possible. So 0 isn't going to work. So what I'm going to do is I'm going to put an open circle at 0. That means 0 is not included in our solution graph. Anything up to 0 on a certain side would work. Now, we want everything less than 0, so that would be over here. Squiggle, 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 and we've got it. Now, that was kind of nice. You'll notice when the inequality sign is pointing to the right, we shade to the right. And when it's pointing to the left, we shade to the left. Well, that's not true in this case. So we have to make a little bit of a change. Here, 7 is greater than or equal to x. Now, I could graph it like this, but it's always best to turn it around so the variable is on the left side. And if I switch the side of the variable, I have to switch the inequality sign as well. See, this inequality sign was pointing at the x, and if we switch it, it still needs to be pointing at the x. Now I can graph. So I'll put 7 in the middle. And the tip on this is when we have this equals here, that means we're going to have a closed circle at 7. That means we like 7, and 7's going to work. And now since it's less than or equal to 7, that means I can squiggle, squiggle, squiggle everything to the left. Now the one inequality sign I haven't talked about yet is, what if we have x does not equal -8? How do we graph that? Well, here's how we graph it. I put -8 right here. And -8 is the only number that fails. So what I do is I put an open circle at -8. And that means anything except -8 works. And that's how I graph that. Now, a side note, if we were just to graph x equals -8, we just put a point like I did earlier in the video at -8. So finally, let's say we have x is less than 10. And somebody comes along and says, okay, we've got all these choices here. And I want to know which one of these numbers would work in this inequality. So if I take -5 and put it in for x, is -5 less than 10? Yes, it is. That works. Is -1 less than 10? Yes, also works. How about 3? Is 3 less than 10? Sure it is. How about 7? 7's also less than 10. How about 10? Is 10 less than 10? No. And how about 12? Is 12 less than 10? No. So with equations, we only have one solution if it's an equation with just an x. And it's x to the first power. But with inequalities, we can have more than one solution. In fact, we can have an infinitely amount of solutions for the inequality. More on inequalities and how to solve them coming up in a future video. We'll see you then.